We've gone through, we've prepped the floor, and as you can see, the floor now has kind of a white appearance to it. As you saw the tool and the different process of how we did that, that can be accomplished either through that machine, or the other way that we can do it is through muriatic acid and an acid etching. And you can consult us as far as how to do that, because there's a certain process that we'd like you to do when mixing that up to get the right concentrate, and also application-wise of what the best way of doing that is. So now we've got the surface prepared, we're ready to start putting product on. Key part before that is that we've had to go to the homeowner and find out what do they want for a color on the floor. So what we ended up with is they've chosen a color like this. We've got it pre-mixed in the product, and what we're using now is what we call a two-component epoxy, to where there's a part A and a part B. Those will be mixed together and then applied to the floor. Now the question is, why are we using this product versus another one? Well, as Greg said earlier, the reason that we're doing the floor is not just because we want a certain appearance, but we also want something that is resistant to chemicals. And in this type of environment, we've got road salts, but we've also got the issue of what they call hot tire pickup. That when a vehicle comes in, a rubber tire is chemically different than when it is cold. And a regular coating, if it's on this floor, will react to that hot tire and then get pulled off. So what we're going to do is we're going to go with an epoxy coating. We've picked the color out, and then we're going to mix that together. We're going to apply it, and then we're going to put a flake onto it.
That, like Stu said, this is not like paint. It's actually a two-part. So when we put the two parts together, they chemically react. So we've got a certain amount of time that we've got to use this product, or it will harden. Even if I put a lid on this and try to use some tomorrow, it'll be hardened and it'll be shot. So we've got a couple hours to work with it. We like to move pretty fast, just depending on the temperature, humidity, and everything. Now, as this is a converter, it's very, very thick. Sometimes we even need a trowel or a squeegee or a spatula to get it out of the can because it's so thick.
One of the things, as we've talked about this, because it's a part A and a part B, they can't be used separate. They need to be mixed together. And as these get poured out of the containers, no problem with what comes out of it at this point. The key part is that when they mix this together, whatever is in there from that point, you use what pours out. You don't want to use anything that's on the edges, because again, those are areas that possibly don't get activated. The way this product works is that when part A and part B mix together, it generates a heat, and that heat is then what causes the product to cure and react quicker. So on a warmer day, it actually will speed up the process. A colder day, we have a longer open time. So the key part is once you've mixed it up, you've got a certain amount of time to use it. Otherwise, it's no good.
And we're going to add, this is a T10, which is a special thinner that's just made for this particular product. We're going to add some of that into it, just to get it to penetrate a little bit better into the concrete.
Another part that we want to remind people is that when mixing it, depending on the brand that you're going with, the mixing instructions do change from product to product. The amount of time that it gets mixed in the bucket, and then also what they'll call a digest time, which means once the two have been mixed together, there needs to be a certain amount of time before it's applied so that they completely react to each other. We're ready to put her on.